Hello. Alright, so that's going. Alright. Okay, I'm coming. I want to get this up for you. Desktop, open, desktop, this, that, and that. Okay. Alright, there we go. Alright, so this is it. One hundred, and save. Great. Alright, welcome to this math class. I want to say it's a big deal that you're here. It's really great. The aim is that through these classes you will get a 1 in CSEC math. That is what I want to ensure you get, but that is also what I want for myself as well. I want to ensure that I get X amount of 1s through all these students, right? So what Adorned is that it's an online platform that you will learn and practice math. So it comes in 3 forms: the mobile app, which is launching this week coming, the website, which is also launching this week coming, and the live stream classes, which were already started since September 1, I believe, right? So what it is that you have the mobile app that gives you unlimited exercises. You can exercise your math and practice your math. It's going to launch with just number theorem, which we're doing now, and it'll continue to grow. Same thing with the website. The website will launch and it'll have tutorial videos you can watch in short snippets to learn and practice the material. It'll have text that you can read to understand the material as well, and it has some pictures that you can go through to understand the material as well. So the website allows you to message me any questions you have beyond email, but you can message me there. Message general questions, because there'll be a group of us. All of us in the class will be on this one website in this one class learning together. You can submit videos as to what you understand, and you can try to teach it yourself, and we'll post it on the website as well. The website will have a leaderboard to count all the points you're getting through the app, through doing the work on the website. So it's an entire system of learning that you're getting. The prices will come out for the website next week as well. It's $2.9 per month up to $5.9 per month. And it's all great to ensure that you get a 1 in CSEC math. Alright, that is my goal, that is my aim. This is the third stream. So the first stream was going through the numbers, what numbers are, how they relate to each other, the categories and groups that they're in. The second stream that I had 2 days ago, which is the number line, I went through moving up the number line and how the number line, in respect to how the numbers are beside each other, relate to addition, subtraction, multiplication, and division. And then we looked at greater than sign, less than sign, and ranges. Now today we're looking at addition, subtraction, multiplication, and division again, but as it relates to the times table, as it relates to associative and cumulative laws. What we're going to go through now today is what you will do every single day for the rest of your life. Now, I am not showing you what to do or how to do it, which I am, but the goal is speed. Speed is one goal because everybody can do math. When I show you the math, you're going to see that you can do it as well. But the issue is, when it comes to CXC and being in the exam, is that you're timed. You have to do the math in a certain amount of time, and that is the goal. That is the goal, to ensure that you can finish the entire paper correctly, but more importantly, within the time. So what I'm showing you today is how we're going to be able to look at the numbers and figure out the fastest way to do our calculation and move on to the next question. Alright? Now, I want to say something about the fastest way. Alright, yeah, so there are different ways you can move through the equation. There are different steps you can take, and that's what we're going to look at. Now, you can use a calculator and pull out a calculator whenever you want, personally, but I don't want to use calculators in this. We don't just use calculators at all. Alright, because we can do the math, we can exercise our brain, and we're going to be able to, we want to be able to do this throughout days of our lives. Life, not the TV show. Alright, one moment please. Alright, so the first thing I'm going to look at is addition. Alright, when you have two numbers, for example, let's put this here. When you have two numbers, for example, 56 and 14, right? What happened is that when we were in younger classes, and we were in smaller classes, you would do the 1's 10 situation and you put your 14 here, and you would get 6 plus 4 is 0, carry 1, that's 5, 6, 7, say you get 70, alright? That is great math, that is good math, you must know this math. But when we're in exams or we're trying to move fast, we have to be able to look at how we can simplify this quicker to move faster. And that is what we're looking at. If we look at 56, right? We have 56 and 14. How can you break up 56 into more easy numbers? What easy numbers when you come to 56? If you look at it in terms of money, right? For the Jamaican money, it's a $50 paper and $6 That's 2. 2 is simpler than 3. If it was 3 parts, it would be a $50, a $5, and a $1. Right? But we can keep it as $6. So 56 is 50 plus 6. And then let's look at 14. 14 is what? If you were to make 14 simpler, what it would be? It would be a 10 and a 4, right? When you see this now, you quickly can add up the 50 and the 10. You know the 10 times table, you know your 10s already, 50 and 10. That's automatically 60. And then the 6 and the 10, the 6 and the 4, these up here, so now 6 and 4 is 10. You know that automatically from first grade, 6 and 4 is 10. So you get 70. We're not seeing everything, are we? Alright, I'm going to do it again. But what I'm saying is that the 56 can separate into 50 and 6, or the 14 can separate into 10 and 4, and then you can do it quickly. So what I'm saying is, when you see numbers, look at the relationship between the numbers, or what relationships you can build out of a number. 14, you know, is a 10 and a 4. 50, you know, is 50 and a 6. 6 and 4, you know, is 10. So you can automatically look at these and say, well, if I have the 50 plus the 6 plus the 14, I can say 6 plus 14 is 20, so 20 plus 50 is 70. These are the calculations you do quickly in your head. Right? So I want you to be able to look at a number and say, what simple numbers can I put together to make up that whole number? So let's look at it again. If you had 82 plus 23, well, that's too easy, don't it? 82 plus 23 is, I know 82 plus 20 plus 3, so that is 102 plus 3, which is 105. Is that correct? Remember, you can message me. Message me below on the WhatsApp number. Right? So, this is something you have to practice. Practice, practice, practice. What you can take out from two numbers. So, again, when you have 27 plus 33, right? 27 plus 33. What you're seeing here is 7 plus 3 is always 10. You know that already, right? 7 plus 3 is always 10. So, that means if you take away the 7 out of this is what? 20 plus the 7, and this is 30 plus the 3. Are you seeing these numbers on the board? Great. You know that the 27 is the 20 plus the 7 plus the 30 plus the 3. So you know 20 and 30 is automatically 50. You know that already because you count $10 all the time. 10, 20, 30, 40, 50. You know that. So that's why this now 30 plus the 20 gives you the 50, plus the 7 plus the 3 is 10. So your total is 60. Right? You know something else as well? Let's look at another way to do this. As I'm saying again, today you have to be able to look at the numbers and see a relationship between the numbers. Look at 27. Where is 27 on the number line? We did the number line yesterday. You have the number line and all the numbers are related. So you have 26 up here and it's coming from 0. So you have 0 coming from here, so and it's carrying and it reached 26 right here. I'm going to draw it some more so you can see it right here. So down here, so it's all a bunch of numbers and it comes to 26, then 27, then 28, then 29, and then 30. So if you're at this number here, if you're at 27 here, you already know that from 27 to 30 is 3 steps you have to move. 1, 2, 3. This you should know already. 27 is just 3 steps back from 30. So that means if you have 33 here, then that means that you can put the 27 plus the 3 plus the 30 over here. So what I've done is that I've taken the 3 out of the 33, I've placed it with the 27, and I've left 30 alone by itself. Right? Because I know the 27 plus the 3 is going to give me, the 27 plus the 3 is going to give me 30 plus 30. Alright, so what you want to be able to do is to look at the numbers and say where they are on the number line and how much shift they need, how much movement they need from left to right. Let's look at another set of numbers. 55 plus 13. 55 plus 13. That's easy. We have a 10 here, so and a 3. 3 plus 5 is 8. You know that? And then the 10 with the 50 gives you 60. It's the same thing. We know this already, where when you were doing this in primary school, prep school, it was adding the ones together, adding the tens together. It's the same thing. We're saying the 50 plus the 10, which will be the tens, plus the 5 plus the 3, which will be the ones. Alright, so therefore 50 plus 10 is 60, 5 plus 3 is 8, so you get 68. Alright? Is that right though? Alright. Now, what I'm showing you is the addition part. What if we look at the subtraction between two numbers? This is the same movement along the number line. So if you have 78 take away 28, okay, that was too easy, don't it? Because you know you're taking away 8 from this, right? So your 8 is going to cancel, so you're going to get 70 minus 20, don't it? And then 70 minus 20, you know, what is 70? How far, what is the next number to 70? The next significant number, I should say. The next significant number to 70 is 50, right? Because when you're looking at numbers, or you're looking at money, you look at 0, then 50, then 100, and so forth. So 70 is close to 50. How far is 70 from 50? 20. So what you have is 70 is equal to 50 plus 20. So if this is the 20 part that is on the outside, right? And then we're going to subtract 20. That means you're only going to have 50 left. You understanding? 78 minus 28. Again, 78 minus 28. What we're saying is that since you have an 8 in the ones and an 8 in the ones here, so we can subtract the 8s alone. Right? Again, 78 is made out of what numbers? It's made up of 70 plus 8 gives you 78. Alright? That's one house. And then from that house, we're going to minus the 20 plus the 8. Right? This 70 plus 8 gives you the 78. This 20 plus 8 gives you the 28. So therefore, if we're taking away all of this from out of this, that means that the 8s are going to disappear. So this 8 gone and this 8 gone, because what we're doing is taking this out of this. So the 8 is gone, and then we have a 20 need to come out of the 70. What is the 70 made out of? The 70 is made out of a 50 plus a 20, right? And we're taking away a 20 out of it. So that means the only thing we'll have is 50, if you can see it on the board. The only thing we'll have is 50. That's the subtraction there. What about 92 take away 35? Alright, 92 take away 35. This helps by knowing your times table, right? We know that 92 is what? Alright, let me just guess my answer now. I'm guessing that the answer is I'm guessing the answer is 50, 53. Let me see if that is correct. Did you guess your answer? What do you get if you guess? Alright. Why I guess my answer was that is because I was saying that 92 is 30 plus 30 plus 30 plus 2. That's in one house. And then I'm going to subtract 30 plus 5 in another house. Alright? And so what's going to happen is that my 30 is gone in both. So it's going to be 30 plus 2 minus the 5. So therefore, on the number line from minus 2 to 5 would be what? If I have a number line 0, and what 1, 2, at 2 here, so this is 1, then 2, and then going backwards, the first one is going to be what? -1, -1, then -2, -3, -4, -5, right? Then if we're at +2, which is here, and we're going to go 5 steps back, it's going to be 1, 2, 3, 4, 5. So this is what I get, -3. So what I'm saying is that because that is -3, what happens is that this therefore becomes 30 plus 30 minus 3. Right? And then 30 minus 3 we know is 27. So it's 30 plus 27, which is 57. So I got it wrong. My guess was wrong. My guess was 53. It's 57. Alright? So I want to look at it another way. Yes, you can stick this into your calculator, but the more you know the relationships with the numbers, is the better it is for you to run through your questions quickly. Alright, so one more time with this. 90 plus 2 minus 30 plus 5. Alright. Taking the 30 out of the 90 will be 60 plus 2 minus the 5. So it's 62 minus 5. Therefore, on the number line, 62 minus 5. So therefore, on the number line, it would be on the number line, if we're at 62, then this is 61, then it is 60. This is 62. (62), 61, 60, 59, 58, 57. Alright, and so if we're at 62, we need to go 5 steps back. So that is 1, 2, 3, 4, 5. So that is 57. So this is equal to 57. Alright, so if you haven't noticed as yet, there are some associative laws coming in that I want you to be able to see point out right now. So when we're doing 92, and we're saying 92 is equal to what? 90 plus 2, right? But because of math, I want you to also realize that 2 plus 90 is the same thing, right? 90 plus 2 and 2 plus 90 is the same 92, right? And this is not associative, but this is the cumulative law. Right? So, something you should always note is that when you have a number, you can always break it out into smaller parts. Right? You can break it out into these addition statements, and then we'll go into multiplication. You can see you break them out into multiplication. Right? Keeping it going, you can say 88 is equal to 8 plus 40 plus 40, right? You see that? 40 plus 40 is 80, 80 plus 8, 88, right? It's the same thing as saying 40 plus 8 plus 40, right? This is the cumulative. No matter which way you rotate it, you'll always equal to 88, right? No matter how you turn a cake around, no matter how much you pull the pizzas apart and put them back together, you're still going to get the whole pizza, right? As long as all the parts are there, it doesn't matter how you add them, as long as it's all addition, right? Now, this being the cumulative, that no matter how it's broken up, you'll get it. The associative is saying that if you add these two first and then add the third one, you're still going to get the same answer as if you add these two first and then that one. Alright? Even though I have them as 80 plus 40 here and 40 plus 80 here, and then the 40 on the outside, it's the same way if you had done the 40 plus the 40 first and then added the 8 on the outside. That is all. This is the associative here, talking about how you add them doesn't matter. And then the cumulative is talking about how you can break it out into the different parts and still add them together. Alright, so we looked at addition, we looked at subtraction. Actually I want to do one more subtraction, and then we do the times table quickly. Alright, so one thing to note is signs. You know the number line we looked at a while ago? When we looked at the number line a while ago, we saw that past 0, we end up going into the negative numbers. Let's look at that again. When you add 0, 1, 2, 3, 1, 2, 3. When you come over this side past the 0, you get negative 1, negative 2, and negative 3. Remember that, right? So once you're going past 0, you're gone into negative territory, right? So that means that the bigger the negative number is, the smaller the number is. The bigger the positive number is, the bigger the number is. So down this side is always small numbers, up this side is always big numbers. Now, this is just the sign of the number. So this is the sign, this is the magnitude of the sign. So these are all the negative numbers. Over here, you don't see a sign on them, because if there is no sign, it means that it's a positive number. But yes, there is a positive sign in front of all of these. It's just that for simplification, if there's no sign, it means it's positive, or we don't put a sign on it, because everybody knows that no sign is positive. Alright, someone says the answer is 57 to that was what, the 62 plus 25 or 62 minus 25. Yes, thank you. 57 is the right answer. Alright. Alright, so now we talk about the positive and the negative sign. Now let's talk about the operation, right? We talked about addition and we talk about subtraction. Alright? What I want to go through with you is signs versus operations. Alright? Now, these are the signs of the number. 0 is neither positive or negative. These are negative numbers and they go all the way up to 1,000 to, negative 1,000, negative 1 billion, negative 3 trillion. And then this continues in positive sign, it continues to positive 2,000, positive 5 million, positive 28 billion, right? It continues positive, right? The addition and the subtraction now are the operations. What do you do with these signs? When you're adding, you're moving up the number line. When you're subtracting, you're moving down the number line. But the sign here can reverse whether you're moving up or down. Alright? So let's look at that. If you have the number $82 plus negative 45. Alright? Are we seeing that? Alright. 82 plus negative. This is the addition statement, right? We're adding it. But what you see here is that if you had 82, which is all the way up the number line, and you're adding 45, which is all the way down the number line, what is that saying is that it becomes that when you're all the way at 82, you have to come back 45 steps. You understand that? Look at it like this. Look at this right here. If I had, you have negative 3 here and you have positive 3 here, right? If I have, where I have space on the board over here, if I have 3 plus negative 3, right? This 3 here, so it has no sign, like how this 82 has no sign. But that automatically means that that is a positive number, right? Now, we know that already. If you're all the way at 3, that's the starting point here, and you need to add a difference of minus 3 or a space of minus 3. That means from minus 3 to here, so it's 3 steps, right? 1 step, 2 step, 3 steps. So, how do you take away these 3 steps right here? So, that means you have to move from your 3 point, you have to move 3 steps back, and that's how you end up at 0. That was a lot of information. Let me go through it again. Right? If you're at 3, negative 3, negatives is a whole. If you dig once, that's negative 1. If you dig 2 times, that's negative 2. Same way here. If you add 0 and you step back negative 1. If you step back one more time, you step back negative 2. If you're 3 steps ahead and you're asked to step back 3 times, that means that you have to, from the positive 3 that you're right, you have to step back once, twice, 3 times, and that's why you end up at 0. So what I'm showing you is that when you say an operation 3 plus negative 3, a positive number plus a negative number, that is going to be a subtraction automatically. So this is the same thing as 3 minus 3. So this is the same thing as 82 minus 45. meaning that 82 minus positive 45. That's positive 3. Right? Because this counteraction here results in a negative. And so in this question, from 3 going 3 steps back brings you 0. The same thing as 82 going 45 steps back gives you what? Anybody work this out already? What is this when you work it out? This is 82 is 40 plus 42, so therefore it becomes 42 take away 3, which equals to 39. Is that the answer? You're not seeing my working out, are you? What I did was I said the 82 is the same thing as 40 plus 40 plus 2, right? And I'm also saying that the 45 is 45, and because the 45 is 40 plus 5, so because both of them have 40, I'm taking out and it becomes 42 take away this 5 part. Right? Because I write it as a plus, you're probably not seeing it easier. So let me show it to you some more. Again, the question is, what is 82 minus 45? I know that 82 is made up of 40, 40, and 2, and 45 is made up of 40 and 2. Why I chose to break 82 into 40, 40, and 2 is because the second number that I'm subtracting is 40. So I'm saying, okay, 40 is a simple number from this number, and 80, because I know 82 is made up of 80, and 80 is 2 40s, that's why I split it in 40, 40. You understand? It's 82 take away 45. 45 has a 40 in it, and 80 is made up of 2 40s. So that's why I use 40 as my main number in both of them. So when I do that now, I know that what I'm left with after I take out the big 40 is I have 42 take away 5. And that becomes an easy thing to work out. When I'm on the number line, I think about the number line again. If I'm on the number line, and I'm at 42 on the number line, and I'm going back 5 steps, I have to go draw my 5 steps in my mind. 1 step, 2 step, I know that will bring me to 40. So I know already, so it has to be a number less than 40. Numbers that are less than 40 are 30s and 20s, but I'm only going how many steps left? If I've gone 2 steps already, that means I only have 3 steps left. And so 1, 2, 3, so 40 gives me 39, 38, 37. So I have the wrong thing. I said 39, it's 37. Anybody corrected me? Nobody corrected me. Alright, so the 42 goes back 2 steps and then 3 steps bring me to 37. Alright? Math is fun. Alright. That's the operations. Now let's look at some multiplication quickly and then some division quickly. Alright, let's look at this first. Alright, this is a times table. This you'll have to know out of your head perpetually. For as long as you live, you have to know this. Alright? Now, what we're going to do is we're going to go through these quickly, and I'm going to show you the relationships because all of these numbers are related. The quickest way you can tell that they're related is by looking at or highlighting what numbers you see repeating. For example, you see, well, you can see the intersection between 2 numbers, yes, But let me pick out two examples for you. Look at the number 72 right in the center. You see 9 times 8 is 72, but you also see 8 times 9 is 72. That is a bad example actually. What I wanted to show you was something like 28. Is it 28 I want to show you? 28 is the same thing. And 27. Yes, that is what I want to show you. I want to show you how the backwards motion and the forwards motion is the same thing. Let's go through some examples quickly. I need to rewrite this. Alright. First thing I want you to do, not multiplication but times table. Alright, the first thing I want you to know is I want you to know your 5 times table and your 10 times table. That is not only easy, but you can use it in so many other things, particularly when we're doing time. And 10 times table is used because we use base 10 a lot. Alright, so with 5 times table, that is the regular clock that we used to use in terms of the right hand, the small hand and the big hand, and it rotating. So you know already that when the clock is on 3, how many minutes that is? That's 15 minutes, right? What that means is that 5 times 3 is 15 because each number is 5. So when the clock is on 4, that is 20 minutes. So 5 times 4 is 20. When the clock is on 9, that's what? 3/4. So that's 45 minutes. So that's 5 times 9 is 45. We're getting that? When the clock is on 12, I hope you know that it's 60. The same way, if the clock is on 11, it's 55. So 5 times 12, 5 times 11. Are you seeing the 5 times 11? No, you're not. But the 5 times 11 is 55 because that's just before going to the new hour, right? So what I'm showing you here is that the clock already has your 5 times table built in, so you can know that easily, right? From 5 ones, 5 all the way down to 5 12s. The same thing for 10, right? You know your 10 times table already because you can count $10 every single day. 10 ones, 10 sevens, to 10 what have you. And believe me, as much as you know it, you have to really know it. Like when you touch the back of your hand, you can feel that you're touching the back of your hand. So you have to know when you say the 10 times table, you can jump at it. Alright? Now let's look at something that might be hard, like the 8 times table. Right? As I said, multiplication is fast addition. So you have 8, right? 8 times 1 is 8. 8 times 2 is multiplication is fast addition. What this is saying is that you're going to add 8 to itself 2 times. That's it. So it's 8 plus 8, which is equal to, that's not right, 16. Yes, it is right. Alright? 8 plus 8, 16. Now, when you look at 8 times 3, multiplication is fast addition. So it's 8 added to itself 3 times. So it's 8 plus 8 plus 8. But you know 8 plus 8 already, don't it? 8 plus 8 is 16. So it's 16 plus 8, which is 24. Alright? Now, 8 plus 4, 8 times 4, again, is 8 plus 8 plus 8 plus 8. Now, you know 8 plus 8 already, you know 8 plus 8 already, don't it? So that becomes the 16 plus 16, which equals to 32. Right? Or 24 plus 8 brings you to 32. What I wanted to see is that not only the multiplication can be done really fast with the addition, but that you can break the numbers. You can break 32 into 16 plus 16, which is what we were doing earlier, right? And then you can break the 16 into these 8 parts, right? You see the relationship where 32 can come all the way down to 8, right? Being able to look at 32 and say 32 is made up of 2 16s or it's made up of 4 8s, that's kind of information you have to feel and know in your head by practicing. Just time. That's all they're trying to improve. Time. Right? And now we're continuing. What are you seeing? Okay, so I have space here. Alright, so 8 times 5 is 8 plus 8 plus 8 plus 8 plus 8. That's 8 added to itself 5 times. So that's 32 we know from 4 plus 8, which will be 40. Right? And then what it can reach a point where you can just start adding these extra numbers. Right? So 8 times 6 is the same thing as 8 times 5 plus 8 times 1. Right? So it becomes 48. Can you see that? It becomes 48. Right? Again, this is the fast addition. 8 times 6 is 8 multiplied by itself, or added to itself, sorry, 5 times. That's what 8 times 5 is. That's what we'll put here. And then we'll add in another 8, right? Because we're going up one more step. So 8 times 1 is the same thing as 8. So by adding another 8 to this, we get 48. I hope you're understanding. No questions so far. Let's go higher. 8 times 7 is equal to, well, we know 8 times 6 was what? 48. And then we just need to add 8 times 1. Now we just need to add another 8, because to going up to, if 8 times 6 is 8 added to itself 6 times, and 8 times 7 is 8 added to itself 7 times. So that just means that we need to add an 8 to go up to the next step. So 48 plus 8 is 56. Right? And then what I want to see now is 8 times 8 is equal to the same thing as 8 times 4 plus 8 times 4. What was 8 fours? 8 fours was 32 when we did it. So it becomes 32 plus 32. This is not a 2. 32 plus 32. And we know that already. That is 30 plus 2 plus 30 plus 2. So it becomes, these two 30s added together in our minds quickly is 60. These two added together in our minds quickly is 4. So that becomes 64. And that is quick math you do it in your head. Right? You know 8 times 4 already. You're doing 8 times 8, you know, so you just need to multiply it by 2. It's 32 plus 32, so that means that's 2 30s, and that's 2 2s. So 2 30s is 60, 2 2s is 4, 64. Done. Alright? It's best to know your times table, because what you'll be doing is that, for example, when we're doing, look at this. What space I have on the board? What is 8 times 16? If 8 times 8 is equal to 8 times 4 plus 8 times 4, then 8 times 16 is the same thing as 8 times 8 plus 8 times 8. Right? And so, because you know 8 times 8 by knowing the timetables is 64, then it just means that when you say 8 times 16 and you write it down as 8 times 8 plus 8 times 8, you just don't say 64 plus 64. 64 plus 64 is what? We know 60 and 60 is 120. I mean, we should know that. Alright? Let's go through that. What space do I have? This is 64 plus 64, right? we know 60 plus 4 plus 60 plus 4. The two sixes is 12 and the 0, 120, plus the two fours is 8. So it's 128. Right? 128. Because we know 60 and 60 is 120. Why we know that is because we know 6 times 2 is 12. And so 60 times 60 is, okay, that is actually something that we have to go through. Why 60 and 60 is quickly we can see it is 120. But through practice you can do it, or in your regular math that you practice, you'll be able to see it and know it. Alright? But what I wanted to focus on is how, if you know the small bits of your times table, if you know the small bits, if you know 8 times 4 plus 8 times 4, you can quickly see that that becomes 32 plus 32, which will give you the answer for this bigger question. But this type of numbers is not what you'll be getting in CSEC. In CSEC you're getting this, 8 times 16. 8 times 16, you already know that it's 8 times 8 plus 8 times 8. Why you can do this is because you know what multiplication is. Multiplication is just fast addition. So you're taking one set of numbers added together and you're continuing it down the line. Right? That's all you do with this plus. You're adding this set of addition and this set of addition together. That's what we did here. We said that 8 times 6 is the same thing as 8 times is 48, and we added another 8. 8 times 6 plus 8 times 1. That was what 8 times 7 was. Right? So we can break up these numbers like that. Alright. Let's keep going and not look at the time. Any questions so far? Interesting. I have to go look at those failed emails later. Alright, let's look at another times table. Let's look at 12. 12 seems to be hard because it's bigger numbers, but again, it's everything you can do. 12 times 1 is equal to 12, because it only only adding 12 to itself one time. So it's 12 plus nothing else. Right? Next one, 12 times 2 is equal to 12 plus 12, which is equal to 24. Why we know it's 24? Because 12 plus 12 is what? 10 plus 2 plus 10 plus 2. Right? 10 and 10 is 20. 2 plus 2 is 4. So it's 24. We can look at the numbers and break them down into these smaller parts. Right? 12 times 3 is equal to, we know 12 times 2 is 24. So 12 times 3 means that we just need to add 12 one more time. So it's 12 plus 12 plus 12, or which equals to 24 plus 12, which equals to 36. Alright? What I'm saying here is that 12 times 3 is 12 added to itself 3 times. So it's 12 plus 12 plus 12, which equals to 24 plus 12. Well, I was thinking about something else. 12 times 3 is 12 added to itself 3 times, which is 36. Another way you can do it is 12 times 2, which is 24, and then you just add another 12 to give you a 36. So these are two ways I'm showing you here to get the same 36. Let's jump ahead. What is blue? What is 12 times 6? Off the top of your head, what is 12 times 6? No. I'm guessing that it is 72. Or maybe I know the answer out of my head. What I'm saying is that 12 times 3 is 36. So that means I just need, since 12 times 6 is the same thing as 12 times 3 plus 12 times 3, then that means that it's 36 plus 36, right? Which is the same thing as 30. Are you seeing this? 30 plus 6 plus 30 plus 6, right? And then the 30 and the 30 gives you 60 plus the 6 and the 6 is what? 12. The 12 is simply 60 plus 10 plus 2, don't it? So this is 70 plus 2, 72, right? 36 plus 36 is 72. See, that's how you can work maths without a calculator, you know. You just look at the numbers and say, okay, where am I on the number line? What can I move from one number to the next? Just like that, alright? So this 36 plus 36 is 72, right? So what we're saying is that even though the times table starts from 12 and it goes all the way to 12 times 1 and it goes all the way to 12 times 12, if you take the parts and add them together, you can move along the number line, move along the times table, right? So we see we skip from 12 times 3 to 12 times 6, and we can get that without saying 12 times 3, 12 times 4, 12 times 5, 12 times 6 to add up as we go along. We know 12 times 3 plus 12 times 3 will give you 12 times 6. Let's look at another one. What is 12 times 9? 12 times 9 is just 12 times 3, 3 times, don't it? Or 12 times 6 plus 12 times 3. We see that? 12 times 9 is the same thing as 12 times 3 plus 12 times 3 plus 12 times 3. Or it's 12 times 3 plus 12 times 6. Right? So we have multiple ways to working this out right now. Right? You can choose 12 times 3, we know is 36. So it's 36 plus 36 plus 36. Right? Or 12 times 3 plus 12 times 6, which we know 12 times 6 is 72. So it's 36 plus 72. Right? And off the top of your head, what is that answer? We know 7 plus 3 is 10. And we know 6 plus 2 is 8. Is that 108? Am I wrong? Am I wrong or am I right, gentle people? Am I wrong or am I right? Yes. 12 at the very top right, come all the way down to 9 is 108. Okay, great. Alright, so let's look at the next one. What is 12 times 11? Where do I have space? I have no space. Alright, so I'm going to just quickly write this here. Twelve times, this is 24, this is 36, this is 72, this is 108. Alright, so now 12 times 11 is equal to, well, what numbers when added together give you 11? This is what we just did a while ago when we were doing the addition. We said that 11, I'm writing it in black. 11 is the same thing as 3 plus 4, don't it? 3 plus 3 plus 3, 3 plus 3 plus 4, that don't look right. 3 plus 3 plus 5. 3 plus 3 plus 5, right? 3 plus 3 plus 5 is 11. So we know 3 is, for 3 plus 3 is 5, so we know 3 is what? 36 plus 36 plus, or it's 12 times 5. 12 times 5 is this, the 24 plus the 36, don't it? So we did 36 again plus 24. And that is what? Well, it's 36, 36, 36. We did that already before, didn't we? The 36 3 times was 12 times 9 plus 24. So it's equal to 108 plus 24. Alright? Which is the same thing as 100 plus 20 plus 8 plus 4 is equal to 120 plus 12, which equals to 132. Is that the answer? 12 times 11 is 132. Great. So let's review this quickly. Alright, what we're saying is that 11 times 12 or 12 times 11, they're both the same answer. Right? No matter which way you multiply them, they're going to give you the same answer. That is the associative law. No matter how you multiply them, you get the same answer. Now, 11 in itself, when you add them, what numbers you can add together to give you 11. We said the numbers are 3, 3, and 5. 3 plus 3 plus 3, 3 plus 3 plus 5 is equal to 11. But what else is also equal to 11 is 3 plus 3 plus 3 plus 2 is also equal to 11. Right? And that's what we did here. So we said, how can I write this without rubbing out anything? I'm going to try. Okay, write it right here. So we said 12 times 11 is the same thing as 12 times 11 is the same thing as 12 times 3 plus 12 times 3 plus 12 times 3 plus 12 times 2. Alright? The 11 is the 3 plus the 3 plus the 3 plus the 2. Right? And we know 12 times 3 already is 36. So we'll get 36 again. And we know 12 times 2 is 24. Right? What I'm also saying is that because we know 12 times 3, 12 times 2, 12 times 3 is the same thing as breaking down 12 times 11 is the same thing as 12 times 9 plus 12 times 2. Isn't it? Why? Because 3 plus 3 is 6, plus 3 again is 9. These 3's up here, so if we added them together, is 9, isn't it? So that's why 12 times 9 is the same thing as 12 times 3 plus 12 times 3 plus 12 times 3. So 12 times 9 is that part, and then we'll have the 12 times 2 come here for this 2. So 9 here plus the 2 here is equal to 11. So that's why we'll have 12 times 9 plus the 24, which is the 12 times 2. So 12 times 9, we did it already over here, and we said it was 108. So 108 plus the 24. Now, we discussed this already earlier. If you have 108 and you have 24, look at the relationship between the numbers and how you can figure things out. The 108 is 100 and then 8. And the 24 is 20 and then 4. So we can combine the big numbers, the 100 and the 20, and we get 120, and come and add the small numbers, the 8 and the 4, and we get 12, right? And then it becomes a situation 12 times 20 is 32, so your answer is 132. Quick math, right? You'd have to waste time punching into the calculator and then taking it in. Or it might not be waste time depending on how fast you can press the calculator. Alright, that is the multiplication. Now, division, you're still going to use your times table. Let me show you how. Or you might already know. For example, what is 204 divided by 12? CSEC is going to give you that. Right? Numbers that are not on your times table, that's what they're going to give you. Right? The best way to look at this is to say, hey, what numbers in my 12 times table can I use to break up this 204? Right? Looking at these numbers here, for example, how can I break up this 204? Okay, this is actually a very hard one. What is 104 plus 1? No, 102 plus 102, don't it? That's breaking up the 204. But it's 108 here. What is 72 plus 72? Anybody knows that? That's 144. What is 204 take away 144? That is 104 take away 44. That's 100 take away 40. That's 60. Oh, that's good. So therefore, this is the same thing as 144 divided by 12 plus 60 divided by 12. Alright? This didn't work out because these numbers are not on it. So what I did was this. 72 plus 72 is 144. Know that quickly. 204 minus 144 gives me 60. So I know 144 divided by 12 plus 60 divided by 12 will give me the answer for this. This is not the easy way. This you'd probably want to do the long way division of 12 divided by 204. And then you'll get the same answer. You'll get the same 12 into 20 is one time, which will be 12. So therefore you get 20, 12 will give 84. 12 into 84 is this plus 12. This plus 12 is 84, so that'll be 17. Alright? Which is the same thing as 12 into 44 is what? 12 plus 12 into 6 is what? 5 is equal to 17. Alright? But what you can see is that by breaking down a big number into smaller numbers, you can figure out what the division is. You divide 12 into the first part and then you do 12 in the second part, and those answers are there. Alright, before we go, let me do one simpler division and show you what is 72 divided by 4. Alright, we know 72 in our 12 times table was what? 72 in our 12 times table was 12 times 6. 12 times 6 is 72. So if 12 times 6 is 72, then what you have is 12 times 6 divided by 4. Right? What this is 12 divided by 4 times 6, which is equal to 3 times 6, which is equal to 18. Is that right or is that wrong? Right? Because what is happening here is that 72 is breaking down into these two parts, right? And what we're saying is that we're going to divide what this part is, and then that multiplication of that answer will give us the final result. So, by knowing our 12 times table, we can pick out 72 is 12 times 6. And then from that, we can easily break down the 12 divided by 4. 12 divided by 4, 12 times table again, is or 4 times table, 4 times 12, no, 4 times 3 is equal to 12, therefore 12 divided by 4 is equal to 3. Alright, so again, the 72 can be broken out into a multiplication, that is 12 times 6, right? And then the division can be done out of one of the multiplying numbers, which is, we're going to choose the 12 and the 4. Why? Because they have a relationship in the times table. The relationship between 12 and 4 in the times table is that when 4 times 3, the result is 12. So therefore, 12 over here divided by 4, the result is 3. So 12 divided by 4 is 3. The 3 times the 6 that was left is equal to 18. And that's why when you say 12, that's why when you say 72 over 4, you can quickly break it down and get your answer 18, because 18 is not on 4 times 18 is not on your times table. But you can quickly do it by knowing that 4 times 18, you're not seeing 4 times 18 is equal to 72, because 4 times 4 times 12 plus 4 times 6 equal to 72. Alright? Alright, so that is addition, multiplication, subtraction, addition. Looking at the number line, looking at the times table. I want you to study your times table, know it out of the back of your hand, because you're going to see it come up multiple times, being able to look at big numbers and then splitting them up into parts from the times table. Right? 72 is equal to 12 times 6 or 6 times 12, and then you'll be able to do your math faster by knowing your times table. Alright? And knowing that 4 times 18 is the same thing as 4 times 12 plus 4 times 6, because the 6 plus the 12 give you the 18. Alright? So, let's review this again next class tomorrow. I'm going to let you know the time, and then let's keep going and finish number theorem quickly, because I would like to do as much as we can before December. Alright, so thank you for being here. See you tomorrow.